Eating one simple vitamin can reduce your heart disease. Eating chocolate reduces stress in students. New drug prolongs lives of patients with rare disease. Health headlines like these are published every day, sometimes making opposite claims from each other. There can be a disconnect between broad, attention grabbing headlines and the often specific, incremental results of the medical research they cover. So, how can you avoid being misled by these grabby headlines? Well, the best way is to assess a headline's credibility, and for that, you have to look at the original research it reports on. uh, I have come up with a hypothetical uh, research scenario for each of these three headlines. So keep watching for the explanation of the first example, then pause at the headline and you can answer the question. These are very simplified scenarios. A real study would detail more factors and how it accounted for them, but for the purpose of this exercise, assume all the information you need is included. So let's start. Let's start with the study of this cardiovascular effects of a certain vitamin called healthium. This study finds that participants taking Healthium had a higher level of healthy cholesterol than those taking placebo. Their levels became similar to those of people with naturally high l- levels of this kind of cholesterol. Previous research has shown that people with naturally high levels of healthy cholesterol have lower rates of heart disease. So, what makes this headline that I just read misleading? Healthium reduces the risk of heart disease. The problem with this headline is that the research didn't actually investigate whether healthium reduces heart disease. It only measured the healthium's impact on levels of particular kind of cholesterol. The, the fact that people with naturally high levels of cholesterol have lower risk of heart attacks doesn't mean that the same will be true of people who elevate their cholesterol levels using healthium. Well, now that you've cracked the case of healthium, let's try at a particularly alluring mystery: the relationship between eating chocolate and stress. This hypothetical study recruits 10 students. Half begin consuming a daily dose of chocolate while half abstain from it. As classmates, they all follow the same schedule, right? So by the end of the study, the chocolate eaters are less stressed than their chocolate free counterparts. So what's wrong with this headline? Eating chocolate reduces stress in students. It's a stretch to draw a conclusion about students in general from a sample of 10. That's because the fewer participants are in a random sample. The less likely it is that the sample will closely represent the target population as a whole. For example, if the broader population of students is half male and half female, the chance of drawing a sample of 10 that skewed 70% male and 30% is about 12%. In a sample of 100, that would be less than 0.0025% of chance. And for a sample of 1,000, the odds are less. Similarly, with fewer participants, each individual's outcome has a larger impact on the overall results and can therefore skew big picture trends. Still, there are a lot of good uh, reasons for scientists to run small studies. So, by starting with a small sample, they can evaluate whether the results are promising enough to run a more comprehensive or expensive study. And some research requires very specific participants that may be impossible to recruit in large numbers. So the key is reproducibility. If an article draws a conclusion from a smaller study, then that conclusion may be suspect. But if it's based on many studies that have found similar results, it's more credible. So we've still got one more puzzle, and in this scenario, a, a study tests a new drug for a rare fatal disease. In a in a sample of 2,000 students, the ones who start taking the drug upon diagnosis live longer than those who take the placebo. This time, the question is slightly different. What's one more thing you'd like to know when you're deciding uh, about the headline? New drug prolongs lives of patients with a rare disease. Is justified? Before making this call, you'd want to know how much the drug prolonged the patient's life. Sometimes a study can have results that, while scientifically valid, didn't have much bearing on real world outcomes. For example, one real life clinical trial of a pancreatic cancer drug found an increase in the life expectancy of 10 days. So the next time you see a surprising medical headline, just take a look at the science it's reporting on. If, even when full papers aren't available without a fee, you can often find summaries of experimental design and results in freely available abstracts or even within the text of a news article. It's exciting to see scientific research covered in the news and important to understand the study's findings also. Thank you.